y values. So if this is your graph, let me draw that in blue. Okay, so if this is the graph, yeah, the graph looks like this. So this is 0 0, and then this is 4 0. So you can locate that. Write down the equation of the axis of symmetry. Still remember the axis of symmetry? Yes. So if you're not given the vertex form like this, you're given the equation in standard form. So the axis of symmetry is just equal to negative b over 2a. But if you're given the vertex here, then the axis of symmetry is just equal to the x value of the vertex, which is h. So in this case, this is not in vertex form, so we can use this formula, negative b over 2a. So b here is 8, right? Negative 8 over 2 times a is negative 2. Because you can rewrite this as f of x equals negative 2x squared plus 8x. Okay, then x is equal to negative 8 over negative 4. Then axis of symmetry is equal to 2, positive 2. Okay, you got that? No questions? Okay. So that is one of the values. And then to find for the vertex, the y coordinate of the vertex, okay, to find the y coordinate, you just plug in the value of x to the equation. Let me use another color. The function, because the axis of symmetry is x equal to 2, right? And then the axis of symmetry, which is x, that is also equal to the x coordinate of the vertex. Therefore, the vertex here, see the vertex? Vertex is hk, right? And the axis of symmetry is equal to the x coordinate of the vertex, so it is equal to h. So this is just 2 and k. We don't know k, so we need to solve for k. Now to solve for k, we can substitute the value of x, or the x coordinate of the vertex, to the given function, the original function. So f of x, or y, equals 8x minus 2x squared. So let me write that here. So y, let me just delete this. So y equals 8x minus 2x squared. Then we plug in the x value, 8 times 2 minus 2 times 2 squared. So this is 16 minus 2 times 4 is 8. So y is equal to 8. So the y coordinate of the vertex is 8. Therefore, the vertex here is 2, 8. Yeah, you got that? Okay, we move on to the next one. Next one, number 5. The following diagram shows part of the graph of a quadratic function f. The x-intercepts, okay, we're given the x-intercepts negative 4, 0 and 6, 0. And the y-intercept is at 0, 240. Write down the function in the form of fx minus 10 times x minus p times x minus q. Okay, so letter A, f of x equals negative 10 x minus p times x minus q. We did this last time. Remember? P and Q. The one we solved last time. That P is, let me send you. Where is that? I think we did this. That is A times X, X minus P. X minus P. Let me look for that. X minus P, X minus Q. What's this? This is not slope. This is not slope intercept form. I know slope intercept form. I know. Yeah. Oh, f of x. I meant not slope intercept. Intercept form or factored form. So a times x minus p times x minus q, where p and q are the x-intercepts. Remember this? So p and q, we solved this last week, something like this. So it is we're given the function in factored form or intercept form. So p here and q are x-intercepts, where f of x or y is equal to 0, because you need to set y equals 0 to find the value for, what's this, the x-intercept. Now we need to write down the equation in that form. So f of x is equal to negative 10. Negative 10 is our a. X minus, what's our p? P can be negative 4. So x minus negative 4 times x minus 6. Right. And then negative 10 times x plus 4 times x minus 6. So this is now our equation in factored form or intercept form. Now it says we need to find another equation for letter B, another expression for f of x in the form of f of x equals negative 10 times x minus h squared plus k. So this one is in vertex form. We can expand this one, this equation, because we know that the axis of symmetry, x is equal to the x coordinate of the vertex, because the vertex is hk, right? So we expand that, and then we get the axis of symmetry using negative b over 2a. So let's expand. F of x equals negative 10. X plus 4 times x minus 6, we use FOIL. So this is x squared plus 4x minus 6x minus 24. So this is negative 10 times x squared minus 2x minus 24. Then we have negative 10x squared plus 20x plus 48. So this is now our equation. Now we can solve for the axis of symmetry. Okay, I will write here in blue. Axis of symmetry is equal to negative b over 2a. Then s is equal to negative 20 over 2 times negative 10. So this is negative 20 over negative 20 is equal to 1. So the x coordinate of the vertex is equal to 1. You got that? And now we can solve for the y coordinate of the vertex by substituting the value of x to the equation. Maybe I'll use another color, maybe green. Okay, here, so it won't be confusing. Or maybe I'll just delete this. Okay. This one. So our equation is f of x equals negative 10 x plus 4 times x minus 6 from the previous problem, letter A. And we got the value of x. Then we find y. So negative 10 times 1 plus 4 times 1 minus 6. So this is negative 10 times 5 times negative 5. So this is 10 times 5. 50. What is 50 times 5? Negative 50 times negative 5. Okay. Therefore, the vertex is to 50. Vertex is 1 to 50. And it makes sense, right? Looking at the graph, given graph. So we got it correctly. Alright. So the equation here would become, see, the question is, for letter B, we need to write the equation in the form of vertex form. So our equation would become f of x equals negative 10 times x minus 1 squared. K is 250 plus 250. So this is the equation of the second one. And the equation of letter A is this one, in factored form or intercept form. Okay, letter C. Can I delete this one, the first part? Or maybe okay. Okay, so let's do letter C. Show that f of x can also be written in the form f of x equals 240 plus 20x minus 10x squared. I think letter C is referring to question B, right? So question B, we got this function in vertex form, f of x equals negative 10 times x minus 1 squared plus 250. So we prove that this equation can be written in this way, 240 plus 20x. So let's expand this. So this is negative 10. What is x minus 1 squared? X minus 1 is squared is x minus 1 times x minus 1. So this is x squared minus x plus 1 plus 250. You FOIL that. And this will become negative 10 times x squared minus 2x plus 1 plus 250. Then negative 10x squared plus 20x minus 10 plus 250. So this is just negative 10x squared plus 20x plus 240. Or we can write this as 240 plus 20x minus 10x squared. See, they're just the same, right? So that means the equation in the vertex form can be written in this way. No questions on this? You understand? So it's just like you're solving everything algebraically. So you just have to take note that the axis of symmetry is equal to the x coordinate of the vertex. And to find the y coordinate of the vertex, you just substitute the value of x of the vertex or the x coordinate to the given function. Alright? Okay. Then we move on to number 6. The diagram shows parts of the graphs of y equals x squared and y equals 5 minus 3 times x minus 4 squared. Where is the diagram? Oh yeah, because it doesn't have a diagram, right? Okay, so we go to 20. Okay, find or consider the function f of x equals 16 over x minus 10 plus 8, where x is not equal to 10. Now write down the equation of the asymptote. Asymptotes. Asymptotes. So vertical asymptote, that is y, right? Y, the value of y. And then horizontal asymptote. No, vertical asymptote, the value of x. Horizontal asymptote is the value of y. Okay, to find the asymptote, yeah, a vertical asymptote, let's say this is 10 here, 20, and this is our vertical asymptote. So the graph would be here, because I was trying to graph it, but it doesn't touch the end. It doesn't touch the vertical asymptote, which is x equals 10. But now to solve for the horizontal asymptote, I forgot to say, a vertical asymptote is a line x equals a, where the function grows to infinity or negative infinity. So the graph shoots straight up or down near the x value. So you can find the vertical asymptote by setting the denominator to 0. That's why I set the denominator x minus 10 equal to 0 to solve for the value of x. We don't we exclude any values that values horizontal asymptote. This is the value of y, y equals b, as the graph approaches to infinity. So x approaches infinity, or x approaches negative infinity. And it depends on the degree of the given function. Okay, so take note that there are rules in finding the horizontal asymptote. It depends on the degree of the numerator and denominator. Let's say our function is f of x equals p of x over q of x. Let's say we denote the numerator as n. What happened to my voice? N. And the denominator as m. Okay, when n is less than m, the horizontal asymptote is equal to 0. Then when n is equal to m, then when n is greater than m, there will be no horizontal asymptote. Okay. Check this. Okay, I think we're on the right track. So when n, or the degree of the numerator, is less than the degree. You know the degree? Degree meaning exponent, the highest exponent of the function. Like, say for example, this one. the degree of the denominator is 1 because the highest exponent there is 1. Alright, like if you're given x squared plus 2x plus 8, the degree here is 2 because the exponent of the leading term is 2. Okay, so when n is less than m, then the asymptote is equal to 0. And when n is equal to m, we just divide the leading coefficient, okay, leading coefficient of p of x divided by the leading coefficient of q of x. And when n is greater than m, then there is no horizontal asymptote. Now let's take a look at the function. The function is 16 over x minus 10. What is the degree of the numerator here? Is it 1 or 0? Yeah. So the degree of the numerator is less than that of the denominator. You can just graph this. Oh, sorry. It's not 16 over x minus 10. We have plus 8. Oh. So we can... Yeah, I was... What? So we can write the function as f of x equals 16 over x minus 10 plus 8. We get the LCD, right? X minus 10. So this is 16 plus 8 times... what's this? X minus 10. So I was like, wow, I graphed it and the horizontal asymptote is not 0. So this is 16 plus 8x minus 80 over x minus 10. Then 8x. What is 16 minus 80? Negative 74. Alright, now we can identify now the degree of the numerator and denominator. So the degree of the numerator is 1, right? And the degree of the denominator is 1. Therefore, n is equal to m. So the y asymptote, horizontal asymptote, which is y, is equal to the leading coefficient of the numerator, which is 8, divided by the leading coefficient of the denominator, which is 1. So the horizontal asymptote is 8. My brain froze a bit. Yeah, it froze. Okay, so no questions on this or in finding the asymptote? You just take note that for the vertical asymptote, you set your denominator to 0. And for the horizontal asymptote, you check the degree or the exponent or the highest exponent of the numerator and denominator. And then the next one, find the coordinates of each intercept. What does this mean? Maybe x and y. Yeah. Can I delete this? So maybe the x-intercepts and y-intercepts. So we can do this. 0 equals 16 over x minus 10 plus 8. This is for the x-intercept. Then we subtract 8 from both sides. Then we have negative 8 equals 16 over x minus 10. Then we multiply x both sides by x minus 10. So this is negative 8 times x minus 10 equals 16. Then we distribute negative 8. So that is negative 8x plus 80 equals 16. Then we subtract 80 from both sides. So this is negative 8x. What is 16 minus 80? Negative 74. Then divide negative 8. Then x is equal to, what is 74 divided by 8? Yeah, why is it decimal or in fraction for a while? Oh, 64. It should be 64. So, yeah, 64 divided by negative 8. So this is 8. It's not 74. So the x-intercept is 80. And now we solve for the y-intercept. To solve for the y-intercept, we set x equals 0. So y is equal to 16 over 0 minus 10 plus 8. So y is equal to 16 over negative 10 plus 8. Then this is, they're divisible by 2. So this is 8 over negative 5 plus 8. Then we get the LCD. Negative 5 times 8 is negative 40, right? So this is negative 32 over negative 5. Therefore, y is equal to 32 over 5. So the y-intercept is 0, 32 over 5. Okay, you got that? And then it says we need to graph this. 5. We need to graph. Can I delete this one? The bottom part. Okay. So let's graph this. We have the x-intercept is 8, 0. So let's say this is 8, 1, 2, 3, 4, 5, 6, 7, 8, 0. And then the y-intercept, that is 0, 32 over 5. What is 32 over 5 in decimal? So 1, 2, 3, 4, 5, 6, 7. So this is 6. So maybe somewhere here. Then we can assign values. Values for, this is not a parabola. Okay. Or we can just do like this. It's not accurate. The graph should look like this. Okay. Vertical asymptote. We know the vertical asymptote. What's the vertical asymptote again? X equals 10. 8, 9, 10. So it should be here. So the graph shouldn't touch the vertical asymptote. There. And then horizontal asymptote. What's that again? vertical asymptote, because we expand that, we divide the degree, no, we divide the leading coefficients, because the degree of the numerator and denominator are just equal. That was 8, right? So the other part shouldn't, okay, shouldn't touch the horizontal asymptote. So this is the horizontal asymptote. So the graph will be here. But I should look. Yeah, so that's how to graph it. Yeah. Okay, I think we did that correctly. Number 20. So we write down the equation of each asymptote, coordinates of the intercept, x and y. Then we sketch the graph. This is the graph. Now we move on to 21. Can I delete this? Alright. The diagram shows part of the graph of the function f of x equals q over x minus p. The curve passes through point, okay, so we have point 310. Well, we didn't do this. Oh, I think I remember this problem. Yeah. Okay. Let's just, oh no, I think I remember I read this problem, but we haven't solved, maybe. Okay. The curve passes through point A, 310. So, and line CD is an asymptote. So what is CD there? The asymptote, that one is a vertical asymptote. So x is equal to, what's that? 1, 2, 3, 3 at 2. Yeah, it's too blurry. And it says the curve passes through point 310. Okay, it's indicated there. Find the value of P and Q. Okay. I think here, from the previous problem, right? Q is equal to, Q and P are the x-intercepts, right? If you can still remember. Let me check the previous problem we did. What's the relationship again, like the P and Q from the factored form to the x-intercept? Yeah, from the function, but then we are asked to find for the value of P and Q, and these are x-intercepts. The problem is we have two unknowns, so we need two equations. This is okay if the equation is like this: 0 a x minus p x minus q. That one is easy. Then you can just set the factors to 0, then you can solve for x or p. Okay, let's try. Okay, f of x, maybe we can derive from there. Yeah, for vertical asymptote, we set the denominator equal to 0, and the denominator here is x minus p. So we set that to 0. And we solve for x. Then x is equal to p, right? And then it says it's given that the line CD is an asymptote, and line CD is x equals to 2. Therefore, p is equal to 2. Got it? And we're given this point 310 that passes through, no, the curve passes through point 310. Then we can use this one. We plug in the x and y coordinates to the function. So our function is this one, f of x equals q over x minus p. So that is 10 equals q over 3 minus p is 2. Then we can solve for q. So 10 equals 9 over 1. No, q over 1. Therefore, q is equal to 10. And p is equal to 2. I think you need to remember how to solve vertical asymptotes, horizontal asymptotes. And then you set your denominator to 0. Yeah. For horizontal, you check the degree of the numerator and denominator. So if the degree of the numerator is less than the degree of the denominator, then the vertical asymptote is equal to 0. No, horizontal asymptote equals 0, y equals 0. If they are equal, then you divide the leading coefficient. So you have to know how to identify the leading coefficients, okay? So leading coefficient is the coefficient of the term with the highest exponent or highest degree. So leading coefficient of the numerator, and you divide that by the leading coefficient of the denominator. Then that is your asymptote. If the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Alright, and in cases like this, you're given P and Q. P and Q are the x-intercepts. Now sometimes and for letter B, I think this is the last problem. Right. For letter B, the graph of f of x is transformed as shown in the following diagram. The point A is transformed to, where's point A here? Okay, that one, that graph is transformed to 3, -10. Give a full geometric description of the transformation. So the transformation here, we flip over the x-axis and the y-axis at the same time. I have a, what's this? Okay, so this is what you're going to do. The image is 3, -10. So what is the original? Original here is, what is the original for point A? Where is point A? Point A is 3, -10. So you transform that. Where is that? Oh yeah, because you flip it, right? So the same value, no, different value for x and y. Okay, so point A, then we can conclude from there. Point A is 1, 2, 3, -11. Yeah. So that means the graph is just, you just add -1. So -1. What's that? Horizontal shift to the right? To the right. When it's minus? Oh, I will check on this, okay? This graph, because it's not really that clear. Let me check the transformation. Because it says the original is -11. then you transform to -10. Oh, you add. So horizontal shift 1 unit to the left because you add 1. Do you have questions?